Hello and welcome to our sharing session. This video supplements a work-in-progress paper titled The SORBET Project, Designing an Immersive Environment which Models the Diffusion of Virus Infection to Help Students of Mathematics Learn Probabilities. Over the next few minutes, I will introduce the SORBET project to you, which we have been working on since April 2020. SORBET is an acronym for Socially Responsible Behavior Through Embodied Thinking. SORBET is a virus simulation to introduce students to a basic mathematical model of epidemiology. The activity comprises participant interaction in a virtual environment, followed by analysis of the diffusion data arising from the interaction in either face-to-face or remote learning contexts. This simulation demonstrates the application of mathematical modeling to real-world contexts and provides authentic context for the learning thereof. My co-author Ling is a mathematics educator by profession, while the work of my team is in the learning sciences. Together, we realized the importance and opportunity of facilitating remote learning, learning from home, particularly in terms of helping students understand the criticality of maintaining safe distancing, as understood through the lens of mathematical probabilities. We wanted to build on earlier attempts at simulating the diffusion of a virus, such as that depicted in the Washington Post article, while taking advantage of the robust body of literature around embodied cognition and Jim Gee's notion of projective identity. We thus conceptualized, designed, and constructed a three-dimensional virtual environment designed around the curricular principles of my team's 6 learnings framework. What causes a disease to spread? Infectious diseases are sometimes transmitted through the air. If an infected person breathes or sneezes at you, how likely is it that you will become infected? Will you definitely become infected? Or could you possibly remain uninfected? To encourage students to explore these questions, we designed the SORBET environment in accordance with what we understand about embodied cognition. We seek to go beyond existing designs for simulations which plots diffusion over time with graphs and scatter plots. When designing for habit forming, we try to design from the perspective of a mind-body dialectic, in contrast to presenting learners with abstract representations in which they have minimal agency. At the end of the 5 cycles, the teacher and the class have access to the interaction data, and discussions can then begin as to who are infected and at which stage. Some questions posed to students to guide them in sense-making include: in your opinion, is the disease a highly contagious one? When you came into contact with the contagious person, did you always become infected? And so on. The contagion sum indicates how infectious the disease is. For a contagion sum of 7, the probability of infection is 6 upon 36, or 1/6. Different contagion sums give rise to different infectious conditions depending on the probability of getting the contagion sum. Another activity for the students to engage in is for them to plot the number of newly infected people against the cycles. The resulting S-curve is the model of the diffusion of the disease. As an extension activity, the probability distribution model can be used. It is important for the teacher to discuss with students the usefulness of the model. Using the data of interactions, the teacher can then guide students in the discussion of how useful the model is to predict real-world pandemic diffusion. Models are based on assumptions, and the teacher needs to help students understand the assumptions made in the model. The process of mathematical modeling consists of understanding the real-world scenario, using mathematical concepts to represent the problem, solving the problem, and interpreting the solution in the real-world context. The process is cyclical and seeks to improve the model. If you would like to know more about the SORBET project, do consider visiting us during the conference at the Conference Project Showcase, where we have a virtual space. We look forward to the opportunity to interact with you. Thank you.